Okay, good afternoon. So, can you hear me from there? Yes or no? Somehow. I don't want to shout, I'm just losing my voice. This room is so big. So, hopefully, you can hear me from the loudspeakers a little bit better if I speak low. Okay, so if you remember, we actually messed up a little bit with GeoGebra last time. So, I tried to see that how we can fix it. And then there were two problems that was left without I have time to go through them and solve them. So what we want to do is just to finalize these problems, and then because this is an exercise session, in principle you have to get time to practice on your own. Okay? But if you don't mind, if you remember, for this problem we had two parts. I solved one part using I solved it myself, but when I was checking it with GeoGebra, I didn't get that. After the class was finished, I realized how to check it, and my answer was correct. So, but for the time being, instead of redoing the same problem again, at least we can solve the second part of that problem, okay? So what was the second part? The second part is that if you have this, you want to simplify this expression as much as possible, yes? So how should I do that? There is nothing that I can simplify here. So I immediately start from this 1. So I would write a minus b over 4 minus 4c. So then it becomes a, which is minus m times 2x minus y times y. And then minus, this means, this, by the way, means 1 over 4 times b minus 4c. So I multiply that expression by 1, 4, which cancel this 4 here. And then I will get what? y1 minus xm. And then finally, I have minus 4 times mx minus a half. Okay? And then let me simplify this expression. So do you remember I told you that we can do it in 2 steps, but it is better to do it in 1 step. So I multiply these two inside, so it becomes minus 2mxy, and then plus my. Yes? Am I right? Yes. And then I go to do the same thing here. Minus y from this side, m from that side, so it becomes minus ym plus yxm. And then I multiply minus 4 in, so it becomes minus 4mx plus 2. And then I start simplifying things, yes. So this one and that one are similar. These two are similar but opposite, so they are gone. So what is left for me is minus mxy. And then I will have 4m minus 4mx plus 2. So that is the answer that actually we get. I don't know how many, because you were supposed to work on this problem yesterday. So I think you should be able to get the same answer. How many of you got this answer if you check it? Okay, so I'm also double checking myself. So if you don't mind, let us go back to GeoGebra again to see how we should do it once more. Okay, so as usual, I go to cast view, and then I can get rid of this view that I don't need. And then if you remember, so what I'm supposed to do, I think if I remember correctly, I have to write this. So capital A minus B, capital B over 4, and then minus 4C. If you don't mind, let me put these dots here, so C. Yes?
Yeah, I've read the documentation.
Yes?
You have to write the multiplication.
You have to. Okay.
Otherwise, it interprets this as a variable named AB.
Yes, yes. Okay. Okay. I can understand, because that's also. Yeah. Okay. So I do it, and then I have to remember to enter, I think. And then if I want to use the substitution, I think after entering things and when I substitute that, okay, then probably I can put the variables here. So minus m, I have to remember to put the dot. So I can use the shift 8 in English keyboard. You can also find it yourself. And then what about numbers, Rasmus? Do you think also numbers needed? So 2x, what do you think? Let us be on the safe side. Okay, it doesn't hurt. It hurts, of course, but not that much. But yes. So this is y. And then I go to b, which is 4 times y, and then I have 1 star 1 minus x, and then star m, and then finally if I go here it is m times x minus a half, and then I press OK. Now it comes here, but then the point is that we want to simplify that again, so I would prefer to write expand this time. I don't know, this is the way that I did it yesterday after you left. So expression, but for the expression I put this $1 or $2, sorry, because this is the second row. So I would consider dollar means row, and then I say the second row, the expression in the second row, and then I press enter. This is the way that I got it. I don't know, you might be able to find a better way, but the solution is actually the same that I got on the board, minus mxy. By the way, when I see it in this way, might be there. If I put a space, that is also working as a product. I don't know. But anyway, so what we got is correct, and this is the way that you should do it in GeoGebra. Or at least this is the way that I found it. Okay, so you can also do it yourself. Okay, so now let us go back to the camera view and then continue our recording. Okay, so now we want to reach this one. If you remember, in Math 2C we talked about this, but let us review this a little bit. So here I have given you apparently a third degree polynomial. Why I say apparently? Because there is no guarantee this number might be 0 and this will vanish, okay? But what is the problem? Apparently I see a third degree polynomial, but I want to make it identically 0. What does it mean? When you say that a polynomial is identically 0, it means that whatever you put for x, the answer is supposed to be 0. So it means that how many values I can put for x to make it 0? Infinitely many. Because you say that you want to make it identically 0, so it means that you, for every value of x, this polynomial should give you a 0. But this is a third degree polynomial, and you know that based on fundamental theorem of algebra, it can have at most 3 distinct roots. Yes? So these two things cannot happen simultaneously unless this is not a third degree polynomial. Yes? It is something that gives you 0 for every value. And this can only happen if these coefficients are all 0. Yes? So be careful when I say I want to make it p of x identically 0. So let me use this symbol, even though it is not very standard. But when I say p of x identically 0, it means that the coefficients should all be equal to 0. Okay? So what I will do, I will make a system for myself, and then I would write 2a minus 6 should be 0, minus a minus 2b plus 5 should be 0, 2b minus c should be 0, and the constant term should also be 0. How many letters, how many unknowns are involved? A, B, C, D. So 4. And how many equations do I have? 4. So in principle, I should be able to solve it. 4 equations, 4 unknowns. Even though we haven't studied 4 equations and 4 unknowns in Math 2C, but the idea is very clear. By the way, this system is extremely simple, yes, because one of them is not actually connected to the others. So from here, you immediately find a is 3. One of them is found. And then you put, for example, by the way, this should also be 0. I can put this a here, and then I immediately find d. So this becomes minus 3d plus 6 is equal to 0. And this means that d is 2. Yes? And then what can I do? I have a. I put it here. By the way, I can get rid of this minus sign because minus a number is 0 if and only if the number itself is 0. Okay? So what happens? This means that instead of a, I put 3, so I can ignore this minus sign, and then I would write 3 minus 2b plus 5 is equal to 0. And then 3 plus 5 is 8, so b becomes 4. And then when b is 4, I can put it in this equation and find my last variable. So this means c is 2 times larger than b. b is 4, so c becomes 8. So these are the numbers that I want. Okay? So remember, if I give you a polynomial, ask you make it identically equal to 0, so it means that all the coefficients should be 0, and if someone asks you what is the basis for that, you would refer to the fundamental theorem of algebra. Okay, but what do you think here? Here I have given you two polynomials. I am asking you to make these two identical. Yes, so I want to make p of x identical to q of x. What does it mean? It means that whatever you choose for x and calculate p for that x, and if you calculate q for the same x, the values are the same. Yes? So do you think this is also somehow related to the fundamental of algebra somehow? Yes, how? Yeah?
Because it's kind of hard to explain, but we have two equations that are similar.
Yeah.
In some way, we should be able to put the equations equal to each other.
Yeah, but that is a little bit of intuition. I mean, if you want to find a connection, you are right. Of course, it is related to fundamental theorem of algebra. How? Because I would say to myself, I define a new polynomial, which is the difference between these two polynomials. Yes? So this is p of x minus q of x. So this is what I define. So let me put a semicolon. R of x is defined by me to be this difference. Then do you agree with me that p of x is identical to q of x if and only if what happens? If and only if what happens for r becomes identically 0. Yes? That is the way that we connect it to this. So I would say that two polynomials are identical if and only if the difference between them, which is also a polynomial, is identically 0. But we already learned from the fundamental theorem of algebra that a polynomial is identical to 0 if and only if the coefficients are 0. Okay? But the coefficients are 0, it means that the coefficients are equal correspondingly. Yes? But I want you to understand that, but if you write it faster in the exam, I will accept it from you. So I mean that if I want to solve that problem myself, what I will do, I will take the coefficients and equate them. But I want you to understand that. For example, I would say that here I have x to the power of 3 with coefficient 1. Here I have x to the power of 3 with this coefficient. So these two numbers should match. I do not have any x squared here. So this means that I have to get rid of this x squared here. So this means that the coefficient should be 0. The coefficient of x is minus 5. So the coefficient of x is this number. They should match. The constant numbers should match. Okay? But this is the way that you connect it to the fundamental theorem of algebra. So in principle, let me just do it once. Okay, in principle. I would say that a minus 1, as I told you, you don't need to write this long way, but I want you to understand that, okay? X squared minus a minus 4b minus cx plus 2c minus a plus d is identical to the other one, x3 minus 5x plus 7, if and only if, let me move x to the 3 to the other side and factor it out. Can you tell me what will be the coefficient then? In your head, just move this one to the other side, it becomes negative x. Negative x cubed. There is also x cubed involved here. I take the x cubed out, a minus 1 is left from here, but another thing is also coming from there. What is that? Minus 1, so it becomes a minus 2. Agree with me? So if I just compactly write this, that's okay. There is nothing that is going to disturb this one because there are no x2 terms, so I would just write it down. Okay, so that might be a little bit tricky. Can you do it in your head? I just want to see how many of you do make it right. So if you want, I can keep the negative sign here, and I would write a minus 4b minus c. I open a little bit of a space for you, and then I put x here. What do you think I will put here in this open space?
5.
Okay, so the point is definitely 5 or minus 5. Which one? Because you need to think, this is minus. When I bring it to the left, it becomes positive. Yes? But if I put positive here, then there is an extra minus sign here, which will make it negative, which is correct. So it should be positive. But if you put negative, there is a negative also here, it gives me positive, but that is wrong because when I move it to the left, it becomes negative. Is that understandable? If you want, I can explain it here. So I have minus a, minus 4b, minus cx, and then I move this to the left, so it becomes positive x. Yes? Now, what I am doing, I want to take x out. So I will take x out. From here, 5 is left, plus, from here, this expression is left, if you want to write it like this. Yes? But then I take another minus sign out. This becomes positive, and this becomes negative. I don't know. Any way that you like it, you can understand. But immediate, oh, what I did? Oh, I made a mistake. So, yeah, sorry. Yeah, it should be negative. Yes? Yes, because I was just saying, so if I move it to the left, it becomes positive. So what is on the left should be at the end positive. So if I put minus sign so that by this minus sign it becomes positive. So yeah, that was my mistake, sorry. And then what happens here? I would write 2c minus a plus d, which is already there. I move 7 to the left, it becomes minus 7. It becomes identical to 0. That is my demand, okay? I demand that this becomes identically 0. But what we just learned, what is happening? It means that the coefficients should all be equal to 0. And if you don't mind, let me suppress this one because it doesn't matter. And then 2c minus a plus d minus 7 is equal to 0. Okay, I have again 4 equations in 4 unknowns, but it is not very hard because most of them doesn't depend on all the variables. For example, immediately if you get a is equal to 2 here, you put 2 here, it becomes 4, so this means b is 4. And now you have a and b, so you put them here. A is 2, minus 4 times b is 16. C is unknown yet. Minus 5 is equal to 0. So what is the answer? It's minus 19. Am I right? This is right. So 2 minus 16 is minus 14. Minus 19. I moved, yes, that's correct. And then I put the number here. Minus 19 times 2 is minus 38. Minus a, which is minus 2. D is still unknown, and then I have minus 7 here equals to 0, so then I can find D. So how much is that? 47, yes. Let me double check again. So minus 9 minus 47. That's it. Yes, that's correct. Yes?
I got a different answer.
Okay, hopefully I haven't done any mistakes. First of all, please check what I have written here is exactly what I wrote on the board yesterday. Yes?
Yeah, I don't. On my paper.
Because might be when I was writing, I changed it a little bit or accidentally or wrote something wrong. Yes?
At the X in the original.
Yeah,
Not up there, but
Here. Aha, okay.
where it's a minus 4b minus c
yeah,
x. It should be
it's 2b for me.
yeah.
Because I took 4 from here.
Yeah, well, in
Yesterday it was 2.
It was 2.
Okay, but anyway, at least I am solving everything correct based on this number on the board now. This is not exactly the same problem that I mentioned yesterday. Yeah. Anyway, can you see any flaw on the one that I am solving right now here on the board? So I am solving this problem on the board, which according to you is not exactly what I wrote yesterday. In yesterday, you are saying that this is supposed to be 2, yes? Okay. But anyway, it takes a long time if I want to change everything. So I solve this problem, and then you can solve that problem. And that is not mysterious that your answers are different. But I think you should be able to get these two the same.
Yes.
Yes? Because the change happens here. So it will affect these two results, but not the first. Okay, so that's good. Any questions? Okay, so you can continue with your own work, and then I will teach you later. And then I will go a little bit faster. So these coming things, identities and factorization and rational expressions, are extremely important. Yes? Not because of the applications. Whatever we want to learn in the later lessons, for example, if you want to calculate a derivative, you have to be very good in simplifying expressions. So that is why we have to practice. I will try to practice a lot about these things, and then we move to the other chapter. Any questions? Okay, thank you.